Welcome to Conversations with STEM, the channel that helps you talk and learn with your children about science, technology, engineering, and math. In this video, we'll be developing a model to explain what happens to an ice cube over time. So why use models? A model is a representation of a system or event. Models help us understand and explain things that are too large, too small, or too complex for us to directly observe. And a model can be any kind of representation. Often we think about diagrams because they're easy to create using just a pencil and paper, but there's lots of different kinds of models. Dioramas, dances, even math equations are models. In this video, creating a model of the particles that make up the ice cube will make our thinking visible about what we observe happening to the ice cube over time. Start by observing the ice cube. Ask your child what the ice cube is made up of and what state of matter the ice cube is. We want to start from the understanding that ice is made of water and that matter can be solid, liquid, or gas. All matter is made up of particles that are too small to be seen. In a solid, these particles are packed very closely together, and they're moving very, very slowly or vibrating. I'd encourage you to pause the video here and consider how you could represent this idea in a model. Did you pause the video? If it was a challenge to represent this idea, let's break it apart into some smaller steps. First, we need to determine what the important parts of the model are. For this model, we want to show that the ice cube is made up of particles too small to be seen, the particles aren't close together, and the particles are moving a very small amount. If you or your child struggle to develop a model, determining the important parts to represent can help focus the idea being shown. For this model, we don't really care about what the ice cube is in or the surface the ice cube is sitting on, so we can get rid of all of that in our representation. I'm going to start by drawing the ice cube. Now, we need to somehow show that the ice cube is made of particles. What if we drew a circle to signify that we're going to zoom in and look at the ice cube more closely, like this? Then, we can draw a small dot to represent a particle, like so. Then I should probably draw some more, and I should make them close to each other since we're representing a solid. Now, all I have to do is represent movement. I'm going to draw short arrows to signify that these particles are moving a little bit in different directions. And there we go. We've made a representation of the three things we determined were important to show in this model. If your child enjoys working on the computer, they could even create a moving model, like this stop-motion animation. One of the great reasons to use models is that they help us expand and revise our thinking as we explore a topic. Watch the ice cube melt and have your child make observations about what is happening to its state of matter. You want to hear your child observing that it's melting or changing from a solid to a liquid. In a liquid, the particles of matter spread out and move a little bit more freely. The heat energy from the surrounding air is being transferred to the particles in the ice cube, causing them to speed up. Pause the video and experiment with your model, modifying or adding on to show what happened to the particles of the ice cube. Make sure to consider what the important things to add to the model might be. For my model, I thought it was important to show that the ice cube was melting, turning from a solid into a liquid. The particles of the melted ice cube are moving further apart, and the particles of the melted ice cube are moving more quickly. To modify my model, I'm going to add water around the ice cube to show that the ice cube is melting. Then, I'll move my zoom in circle to the liquid water to show that I'm now representing particles in the liquid. I'll spread some of my dots out so that I can represent the particles moving farther apart, and I'll make the arrows longer to signify that the particles have more energy and they're moving more. I seem to have a problem with my model. I didn't have enough space to show that the particles were moving farther apart, So I erased some of my dots in my second model. However, now it looks like particles are disappearing when the ice cube melted, and I want to make sure I'm accurately representing the underlying scientific principle, which is that matter can change between states, but the amount of matter is going to stay the same. So I'm going to go back and change my initial model to make sure I have the same number of particles in both pictures. So far, we've been making observations about a visible event and then representing what's happening at a very small level. But how do we develop a model about an invisible event? Have your child watch what happens to the water over a longer period of time. What happened to the water? Matter doesn't disappear, it has to have gone somewhere. We've seen the water in a solid state and a liquid state. The heat energy from the surrounding air is being transferred to the particles in the water and causing it to evaporate or turn from a liquid to a gas. In a gas, the particles are now spread very far apart and moving very quickly. Looking at our models, what's important to add? Showing that the water is turning from a liquid to a gas, showing the particles spreading farther apart, and showing the particles moving more quickly. I'm going to make my ice cube and puddle a little bit smaller because I want to show that I observed them shrinking. I'm also going to add some lines to represent that the water is traveling up into the air. I'm going to move my zoom in picture one more time and make sure I'm drawing my dots further apart, making sure to keep the same number of particles this time, and drawing my arrows even longer to represent the increased energy of the particles. Let's take a look at our models as a complete picture. Does our model over time represent both what we observed as well as the underlying scientific principles? I hope this video helps you have conversations with your child while developing and using models. If you want to continue this activity, visit the Conversations with STEM website in the description box below to create a model of air as it cools and heats. Leave a comment down below and tell us how the conversation with your child went, and visit our forum for questions and discussions about scientific conversations. Thanks so much for watching, and we'll see you next Monday for another Conversation with STEM.